Okay, so hello everyone. I was studying machine learning and deep learning from 3 months, and this topic L1 and L2 was pending, and so that's why now I am learning this. So let's see here, L1 and 2 regularization. So why regularization? Regularization means helps us to stop overfitting. So what is overfitting? Overfitting is when the model start to learn the data. Okay, when model start to learn the data, okay, it start to memorize the data, and it basically you can see read off all the things. It does not understand that how the things actually connected, how the rows and how the data is going together, and means it perform uh, it perform bad on the unseen data. Okay, it does not learn the patterns that how the things connected to each other. So it start to do overfit. And what is overfit? Let's see again. So overfit means when the model start to memorize the data instead of learning the pattern. So this is overfitting. And let's say here, so regularization helps stop overfitting. So if the model is uh, if the model is doing overfitting, then we have to use regularization. So we have L1 and L2. So let's see. Overfitting means the model memorizes training data instead of learning patterns. Regularization keeps the model weights small, so the model becomes simple and generalize generalizes better. Okay, so means regularization basically keeps the model weight small, so the model becomes simple and generalizes better. Means our model will become better, we can use that model. Okay, so L2 means what here? L2 regularization means ridge. Okay, L2 adds a penalty is L2 adds a penalty equal to the square of weights. L2 adds a penalty L2 adds a penalty equal to the square of weight formula. The our new loss will look like this: original loss plus lambda and square of weights. So okay, so let's see here the easy meaning. Like L2 softly reduces big weights. Okay, L2 softly reduces big weights, and weights become smaller but never become zero. Weights become smaller but never become zero. So what? Weights become smaller but never become zero. Weight becomes smaller but never becomes zero. L2 means what? L2 softly reduces big weights. Weights become smaller but never become zero. Why used? Gives smart training. Works best in deep learning. Stable gradients means we use this where gives give smooth training. Works best in deep learning. Stable gradients. L2 L1 means what? L1 regularization means lasso. L1 adds a penalty equal to the absolute value of weight. Okay, so L1 adds a penalty equal to the absolute absolute value of weight. Formula here we have a new loss, loss plus uh, original loss plus lambda, and I think it's a mode. Yeah, it's a mode, I think. Okay, mode of weight. Easy meaning, how we can understand: L1 can make some weights exactly zero. This remove useless features automatically. Oh, so this removes uh, this removes useless features automatically. Oh, that's great. So what is the difference here? L1 what makes some weights zero. L1 makes uh, some weights zero, where L2 shrinks all weight. Means it does not means L2 does not means it does not do anything. like doing the zero weight, doing the zero. Okay, so it only shrink like little bit, so shrink all the weights. And L1 means L1 is what here? L1 here we have lasso. So lasso good for feature selection. Lasso good for feature selection. Sharp penalty not common in deep learning. And so let's see again. L1 means what? Make some weight zero. Means lasso make some weight zero. Good for feature selection. Sharp penalty not common in deep learning. And L2 what? Shrink shrinks all weights. Good for shrinks all weights. Good for smooth training, smooth penalty, and very common in deep learning. What is the code? How we can implement? So L2 regularization. L2 is what here? L2 is here. I think uh, yeah, L2 is ridge. So L2 means ridge regression. So here we have a from sklearn dot linear model import ridge and model ridge alpha 1.0. Then model dot fit have a function here, x trend, y trend. And then how we can see the lasso regression. L1 regularization example from sklearn dot linear model import lasso model equal lasso alpha 0.1. Then model dot fit, like we have to only understand that behind the math, what is the math behind this. And our model is very smart, they will do everything for us. But we have to know that what is the background mathematics, how the things happening internally. So and but here models are very smart. We don't need to do anything like any mathematics, only we have to know that what is the happening behind this algorithm. Okay, thank you.